Introducing Airdrill hammers and bits. Product training and maintenance presentation. Airdrill Hammers and Bits is an Australian-owned and operated manufacturing company. Our employees have a lifetime of experience in design, manufacturing and servicing of downhole drilling tools. Our field engineers are all ex-senior experienced drillers. Airdrill Hammers and Bits has a goal to provide high quality and high productivity downhole tools to the drilling industry. This presentation is a training, maintenance and safety guide to maximize the efficiency, longevity and productivity of your reverse circulation hammer and bits. Airdrill Hammers and Bits is conscious of maintaining and furthering continual growth to the safety of all employees within the drilling industry. Please always follow your employer's company workplace policies and procedures. This presentation will briefly cover introduction to your Airdrill RC hammer and parts, receipt and preparation of a new Airdrill RC hammer prior to drilling, Airdrill RC hammer maintenance, personal protection equipment required to conduct all of these procedures in a safe manner are safety glasses, hearing protection, hard hat, gloves, steel cap boots, introducing your Airdrill RC hammer. Let us begin with correctly identifying the major parts within the assembly of your Airdrill RC hammer. The piston case, the top cylinder, the dig-out sub, which is commonly referred to as the adapter sub, the drill bit, the sleeve, which again is commonly referred to as the shroud, the bearing bush, the piston, the drive sub, the bit ring, the inner tube, the adapter nozzle, the check valve, the check valve spring. We have now correctly named and identified the major parts within the assembly of our RC hammer. Receipt and preparation of a new Airdrill RC hammer. On receipt of a new Airdrill RC hammer, we need to spend a little time to correctly unpack and prepare it prior to use. We like to pack our RC hammers well, so please unpack them carefully, and we would hope you would consider your environment and dispose of the waste packaging thoughtfully. Now that you have your RC hammer unpacked, we suggest moving it to a workbench and clamping it down. Once your hammer is securely fastened, the next step will be to identify thread type and size of the drill rods that you'll be connecting to and running the hammer with. You will now need to select a genuine Airdrill adapter sub that will correctly connect your RC hammer to your drill rods. Grease the thread and the inner O-rings on your adapter sub before screwing it into the hammer top cylinder. Genuine Airdrill adapter subs are designed to lock the hammer inner tube into its correct position. If you are using non-genuine adapter subs, then operational problems such as backhammering and silting may occur. You are now ready to unscrew the drive sub from the bottom end of the hammer and remove the bit retainer rings within. Once removed, you will need to select the correct size bit and a suitable sized sleeve to match your bit selection. We recommend that your sleeve be 1.5 millimeters to 2 millimeters smaller than the drill bit you have selected. Now you are ready to put the bottom end bit assembly together. First, take the drive sub and place it over the bit. Next, we fit the bit retainer ring onto the bit. Lastly, we slip the sleeve over the bit as shown, and you now have the completed assembly ready for fitting to the hammer. Before we fit this complete assembly, we suggest you grease the drive sub thread as shown. You may now screw this completed assembly into the bottom end of the hammer. Please be aware that we now have a pinch point on the hammer between the sleeve and the bit as shown. Further handling of the hammer after this stage should be conducted with the safety of yourself and your fellow workers in mind. Your Airdrill RC hammer can now be moved to the rig, and it is ready for operation. Hammer maintenance. Your Airdrill reverse circulation hammer is a highly engineered pneumatic tool, and just like the engine in your motor car, it requires maintenance and servicing. Look after your RC hammer and it will look after you, providing you with many problem-free meters. Your hammer should be stripped and serviced at regular intervals, and also before extended periods of non-use and storage. We recommend that your hammer is removed from the drill site and returned to a workshop environment when servicing. However, as this is not always practical, and if you are servicing the hammer on the drill site, ensure that you have a clean area in which to service it. Hammer disassembly. Before removing the hammer from the drill rig, you should use the rig's breakout system and ensure that you break apart all the joints that will enable you to disassemble the hammer. Once these are broken, you can remove the hammer from the drill rig to an area ready for maintenance. We would recommend you place the hammer securely in a pipe vise attached to a clean bench so that you can work on it comfortably and safely. Now, with your hammer securely fastened, move yourself to the drive sub end and unscrew the bottom assembly consisting of the bit, sleeve, drive sub and bit retainer ring. You may now break this assembly down further into its individual parts and set aside on the bench. After this, move to the top end of the hammer and unscrew the adapter sub from the top cylinder and set this aside. You will see that you now have access to the SIR clip, located internally at the rear end of the female threaded section of the top cylinder. As you can see in the diagram, this SIR clip retains the air screen, adapter nozzle, check valve and check valve spring. Take your SIR clip pliers and remove this SIR clip. Using your SIR clip pliers again, you will find that you can now grasp the adapter nozzle and inner tube and pull this complete assembly out through the top cylinder. If the inner tube is a little tight, then move to the bottom end of the hammer and tap the base of the inner tube lightly. You now have an assembly which consists of an inner tube, adapter nozzle, air screen, check valve and check valve spring. Break this assembly down into its individual parts and set aside for cleaning and inspection. Now, unscrew the top cylinder from the piston case and set aside. You may now remove the piston by slightly tilting the hammer, allowing the piston to slide out to a point where it can be grasped by hand safely. Please take care, as this piston is the heaviest part of your hammer. Protect your fingers and your toes. Return to the bottom end of the piston case, as you now need to remove the bearing bush from that end. To do this, you must first extract the piston retaining ring. You will require a heavy-duty right-angle O-ring pick and medium-sized flat screwdriver to easily remove the piston retainer ring. Once this is removed, you should now be able to pull the bearing bush out from the bottom end of the piston case. Please note the direction in which the bearing bush was installed. You will need to remember this when rebuilding your hammer. Your Airdrill RC hammer is now fully broken down into its major components. You should now wash and thoroughly clean all these parts in a suitable detergent, degreaser or similar cleaning solution. After cleaning, ensure that all parts are dried completely. This can be assisted by blowing the parts down with compressed air. Individual part inspection and maintenance. Now that you have all your parts clean and dry, let us take a brief look at each component to identify any problems with individual parts that may result in your hammer not performing to its optimum capability when rebuilt. We would advise at this stage, however, that any parts that are obviously extremely worn or damaged be replaced, and that it is good practice to change out all old and used O-rings and seals. New and genuine O-rings and seals will ensure that your hammer operates at optimum pressures after being rebuilt. First, let's start with the air screen. Is it damaged or badly worn? If so, replace it. Now check the adapter nozzle. Pick it up and check for damage or excessive wear. If it appears okay for reuse, then we recommend you replace the O-rings on the large seal area. Moving to the check valve, inspect the large rubber seal on the outside and face of the check valve for damage or wear. Replace the check valve if damage is obvious. Here we show on the left a damaged and rusted check valve. A rubber seal has broken away from the outside diameter with wear evident on internal seal also. This is no longer serviceable and needs to be rejected upon inspection. On the right, we show a used check valve with the outside rubber seal still in good condition and no visible wear to the internal seal. This check valve is still serviceable and okay to use. If you intend to reuse, then turn your attention to the small lip seal in the bore of the check valve, as shown on the screen. Here we show the correct and incorrect orientation of the internal seal in the check valve. This seal is important, and if you're going to replace with a new seal, then it must be installed with the same orientation as the one you remove. If you place it in the wrong direction, the hammer will not operate. Let us now look at the check valve spring. Check the spring closely and look for excessive wear and breakages. If the spring looks okay, then reuse. If you think it may be worn or broken, then replace it. Follow this with the inner tube. Check the inner tube for wear and decide if the inner tube can be used again or if it needs to be replaced. If the decision is made to keep the existing inner tube, then we recommend that you replace the O-rings. Excessively worn or blown out inner tubes can lead to breakages of pistons and bits when the hammer is in operation. Now select the top cylinder. Check the bore and the outside sleeve of your top cylinder for any galling or rusting, as seen on the screen. If your top cylinder shows signs of either of these, then buff these spots with a piece of emery paper. And remember to clean the top cylinder again if you have buffed it. You may also need to replace the O-ring if it is showing signs of wear. Moving on to the piston, examine your piston carefully, as this is the workhorse of your Airdrill RC hammer. Check for any sharp edges, rust spots, galling or heat checking. Shown in picture is severe heat checking and galling to the nose section of the piston. This is proven by the dark blue longitudinal burn marks and scouring that is evident in the picture. Lack of lubrication while the hammer is in operation is the main cause of severe heat checking. This type of damage changes the heat-treated structure of the steel, and shown on the screen is a broken piston being the direct result of lack of lubrication. Heat checking of a piston is the cause of 99% of all piston failures. When finding rust, galling, sharp edges and heat checks on the outside, nose of the piston, you will need to polish with either an emery cloth or an emery wheel mounted on a die grinder. We will now turn our attention to the piston case. Check the wall thickness of your piston case. If you believe it to be too thin and you think it will not last another operation cycle before the hammer's next scheduled maintenance, then replace it with a new piston case. On the screen, we're showing a piston case that has been subjected to frequent and excessive blows from a sledgehammer or such like. This severe type of abuse to the piston case should never happen, as it will lead to failures such as we see in the following image. As you can clearly see, major failures can occur from striking the piston case by hand with a hammer or similar hand tools. These next images clearly show the flared end and worn diameter of a well-used piston case that is now beyond its serviceable limits and should be rejected upon inspection. Now we come to the bearing bush. We need to look for any sign of cracking, severe damage or excessive wear. If any of these problems are evident, then replace with a new part. It is also recommended that you change the bearing bush O-rings. Rebuilding hammers with cracked bearing bushes will lead to failures and major breakages of components within the hammer when in operation. Next up for inspection is the bit retainer ring. Check for any breakages or extreme worn areas. We can see in our picture here a well-used set of bit retainer rings, and clearly visible is a large wear area on the face of the rings. At this stage, we would recommend discarding this set and replacing with a new part. Finally, we shall inspect the drive sub to see if it is still in an acceptable condition and able to be used again. The main concerns will be excessive wear on the drive splines internally and cracks that can appear in the drive sub. Here we can see the internal splines and bearing area on a drive sub, with both areas worn to the stage where the drive sub should now be rejected. In our next image, it is evident that a crack has developed in the thread of our drive sub. Replace your drive sub if these faults are observed. Should you fail to replace badly worn or cracked drive subs, it will lead to internal damage of the piston case as well as shanked and failed bits, as can be seen. This last image shows a used drive sub, but on inspection it shows little wear on the internal drive spline and is okay for further service. Our final part to inspect is the piston retainer ring, which we need to ensure that is not severely worn and that no damage is evident. You should replace the piston retainer ring if you suspect it may be damaged. At this stage, you have inspected and cleaned all your parts. You have rejected any used hammer parts that have not passed your inspection of them, and you have acquired replacements for these. All O-rings and seals on your parts have been replaced if required, and you are now ready to reassemble your RC hammer. Preparation of all parts ready for rebuild. For a quick and easy rebuild of your hammer, it is recommended that you first prepare all the cleaned parts and have them ready to install in the hammer. Make sure to select and clean an area close to where you will rebuild the hammer so you can place the parts once you have prepared them. You will require a small quantity of clean rock drill hammer oil and a small quantity of non-galling zinc-based or equivalent thread grease. You should start by picking up the drive sub and use a small paintbrush to coat the threads with the thread grease, and then place the drive sub down in your clean area. Next, take the top cylinder and coat the threads with the thread grease as highlighted. Then take the rock drill hammer oil and lightly coat the top cylinder's bottom end on the outside and inside as shown. You can use your hands to ensure you have a thin coating of oil. Once complete, place in your clean area. Your piston case should be prepared by pouring a little of rock oil into the bore and then using your hand or small brush to smear evenly around the bore. You will need to stretch your arm inside the piston case from both ends to ensure that you have evenly coated the bore. Continue this process of lubrication and ensure you have a thin, even coverage of oil on all your remaining parts prior to assembly. Reassembly of your Airdrill RC hammer. We recommend that you start the reassembly of your hammer by placing the piston case securely in a pipe vise attached to a clean bench so you can work on it comfortably and safely. Your first task is to install the bearing bush into the drive sub-end of the piston case. You can easily identify this by the piston retainer ring groove, which is machined into the bottom end of the piston case. The bearing bush must be installed in the correct direction for your hammer to operate. Push the bearing bush into the bottom end of the piston case, and you'll find that it will locate against a small step in the piston case, and the end of the bearing bush closest to you will be just beyond the piston retainer ring groove. Now follow with the piston retainer ring and insert it into its groove and ensure that it pops in correctly. Now take the bit retainer ring and drive sub. First, slide the bit retainer ring up against the bottom end of the bearing bush. To complete the bottom end of the hammer, take the drive sub and screw it into the piston case until it locks up against your bit retainer ring. The bottom end of your hammer is completed, and now we can move to the top end of the piston case to continue our rebuild. First, take the piston and slide it all the way up into your piston case, ensuring that the small nose section, which is the strike face end, is pointing towards the drive sub end of the hammer. You may now fit your top cylinder to the hammer and screw it into position. All we have left to install at this point is the final few parts that belong to our inner tube assembly. So take your check valve spring and slide it into the top cylinder, ensuring it is sitting squarely. Your check valve should now be placed over the check valve spring. Now place the adapter nozzle on top of the check valve and push the adapter nozzle until the circlip groove in the top cylinder bore becomes exposed. Take the air screen and place it over the adapter nozzle, ensuring it sits flat against the bottom face of the adapter nozzle. Next, use the circlip pliers to install the circlip into its groove. Finally, you may take the inner tube and slide it down through the adapter nozzle bore and into the hammer until it stops flush with the adapter nozzle face. You have now completed the reassembly of your Airdrill RC hammer. If the hammer is going to be stored before further use, then we suggest you block both ends of the hammer by simply inserting a clean rag into both ends. This will stop dirt and foreign materials entering the hammer whilst in storage. If your hammer is going straight back into use, then it is now ready to be returned to the rig. Thank you for your attention to this presentation, and we would hope it's been of interest to you.